Justine. Justine is a character in the story, and she straps Lynette to a harness. Lynette is the other character. There's three characters basically. They're all based off of friends of mine when I was going to college. Justine straps Lynette into a harness which connects them by a light cable running over a frictionless pulley. Oh gosh, one of these again. All right, Justine has a mass of mj. Makes sense because it's a mass of Justine, right? She remains on top of the roof and a bungee cord. It holds onto a bungee cord at a force of constant k. Lynette jumps over the side of the building, and the system is released from rest and the bungee is unstretched. If Lynette has mass ml and falls a distance h before coming to rest, calculate the coefficient of kinetic friction between Justine's feet and the surface of the roof. All right, let me explain to you what that picture looks like, because I know that in words I can only do so much, but I'm actually going to show you what it is. So we got ourselves, and I apologize, I'm actually drawing at a very weird angle. So we got ourselves a roof and a warehouse, and what I called this problem was called recon. So what they want to do is we got Lynette down here who wants to look inside of a window. So we'll make a little blue window right here. She wants to look inside of a window, and she's going off and hanging off the side of a building. Cool? So we got Lynette, and she's holding on to this right here. We'll put her in a little dress because she's a girl. Actually, there's all girls in this story, so everyone's going to be a dress. Okay, and Justine, on the other hand, is holding the rope. And let's see. Justine is holding onto a bungee cord. I have a little pipe that's attached to it or something like that. I don't know. A house or something. So there's friction here, right here. And let's check out the forces. I see. What force do you guys see? Gravity is not a force, it's an acceleration. But do you want to call force of gravity? Sure. All right, fine. We'll call this force of gravity, which is equal to mass of Lynette times gravity, right? On Justine, there's the force of gravity, but that's mass of Justine times gravity. Cool? What else do you see?
Tension force.
Tension, yes, good. This tension right here is pulling Justine, and that exact same tension is pulling Lynette. Right? So those T's are equal. I'm not going to put little subscripts on them because they're the same T. Does that make sense?
Mm-hmm.
All right, what else force do you see? Anything
Normal
else?
force.
You got the normal force. We got this over here. Whatever that is, I'm going to label that big N. Some people label that FN. All right, any other ones? Yeah, the bungee. The bungee's pulling it. Exactly. I don't know, what do you want to call that? Force B? As in force bungee? Yeah, that sounds good. All right, one last force. I'll give you a hint. It has something to do with the red part. There we go. Force of friction. Force of friction. Cool. Now, there's actually two ways to do this. And so she goes down a height h. She goes down a height h, and there's two ways to do it. One way is to use forces. One way is to use energy. I actually, to be honest with you, I think energy is a easier way to go about doing this. But you got to kind of use, some brains about this one. Cool.
Mm-hmm.
All right. Then that's a wrap on that one. How do I stop this thing? Control F10. Control F10. Shift F10.